Hello, in this video we will look at the Nobel Prize in Physiology or Medicine from 1902, won by Sir Ronald Ross for his work on malaria, by which he has shown how it enters the organism and thereby has laid the foundation for successful research on this disease and methods of combating it. Sir Ronald Ross did have a lecture, but it's very long, so I choose not to use it, but use an article about his work. These are, by the way, illustrations from his lecture, and you can find them, of course, as always, at the Nobel Prize official site. Here, few more of his, I think they're beautiful illustrations. If you want to look better, pause the video or go to the Nobel Prize site. I have used, instead of the lecture, which was, as I said, very long, is a book, an article by Robert A. Sinden on malaria, mosquitoes, and the legacy of Ronald Ross. And I use quotes. In 1895, Ronald Ross was based in Secunderabad in India, where he embarked on this quest to determine whether mosquitoes transmitted malaria parasites of man. For 2 years, his studies were clouded by observations on what we now know to be insusceptible mosquito species. He nonetheless observed flagellation of Plasmodium in the blood meal of these insects, the true nature of which was revealed by McCallum in 1897. Ross' later work also benefited from the numerous observations on insects made by infected by other parasites, including helminth, fungi, and gregorines. He made this early phase of his quest for the malaria vector. Eventually, in July 1897, he reared 20 adult brown mosquitoes from collected larvae. Following identification of a volunteer, Hussein Khan, infected with crescents of malignant tertium malaria and exposure of 8 annas, 1 anna per blood-fed mosquito, Ross embarked on a 4-day study of the resultant engorged insect. This complex study was written up and submitted for publication. Imagine today sending an article to a leading medical journal in which you describe observation on novel objects found on the midgets of just 2 brown mosquitoes obtained from larvae of natural origin that you had previously fed on a naturally infected patient with no appropriate controls and no replicates. What hope would it have of getting past the editor and reviewers? None. Thankfully, Ronald Ross' paper was more fortunate. It was published by the British Medical Journal on 18 December of 1897. His conclusions were understandably modest. To sum up, the putative malaria cells appear to be very exceptional. They have as yet been found only in a single species of mosquito fed on malarial blood. They seem to grow between 4th and 5th day, and they contain the characteristic pigment of the parasite of malaria. So begins one of the most influential stories for malaria research and control. Recognizing the relative simplicity of the research tools available to Ross, the observations made by him and his collaborators using simple bright field microscopy were exceptional. He had just 8 brown mosquitoes that has fed on the patients with P. falciparum gametocytis in his blood. 4 mosquitoes were killed immediately to examine the fabulous process of exflagellation, male gamete production, so critical to the discovery of the blood stages of the parasites by Leveran 17 years earlier. 1 mosquito was dissected on the 2nd day to no advantage, and 2 of the 4 on the 4th day, of which one had 12 substantial cells. The description of these cells, the malarial oocytes, formed through the development progression gametocite, gamete, zygote, ookinete, oocyst, is unmistakable. The characteristic round oval shape, the diameter 10 to 60 microns, the sharp line of the oocyst wall, and the nature of distribution of malarial pigment were reported with precision. The presence of pigment was crucial in Ross's eyes, but even this, his defining character, was nonetheless cautiously considered as potentially being a mosquito-derived product of blood meal digestion. On the 5th day, he dissected the last mosquito and noted 21 cells with the same visual properties but larger, about 20 microns. Few today would complain about oocyst intensities and prevalences such as this. There were, however, no controls, such as mosquito from the same source fed on the crescent chemocyte negative volunteer. In this research, Ross excuses himself, stating, "I have not yet succeeded in obtaining any more of the species of the mosquito referred to," and felt it was adequate to describe results from other mosquito species, including a genus Aedes, not known to be refractory to infection by P. falciparum, fed on different volunteers. While hardly conforming to the concept of a controlled and replicated study, Ross commendably obtained and reported fully a second opinion on the nature of the preparation from Surgeon Major John Smith, whose comments are very detailed. The formaldehyde fixed specimens were then considered to be of such potential importance that they were shipped from Secunderabad to the United Kingdom to be observed by Manson, Sutton and Thin. Their observations and reviews are also reported in the publication. Manson and Sutton enthusiastically endorsed the views expressed by Ross and the drawings. Manson commissioned unquestionably illustrate oocysts that are either undergoing sporoblast formation before sporocyte budding or possible generation, should the pebbled appearance indicate vacuolation. In contrast, Finn sets about a further dismemberment of the interpretation of his four colleagues, concluding, through logical argument, but with no evidence, that they were describing mid-gut epithelial cells in which pigment had been phagocytized from gut lumen. He then diplomatically apologizes for his unsupportive interpretation. We can learn from this seminal publication that is relevant to today's research environment. First, the importance of seizing the opportunity. Second, and related, persistence. Ross recounts that before the reported successful experiment, work in the preceding 2 years examining about 1,000 brindled grey and white mosquitoes had failed to reveal any relevant data. Third, the power and importance of careful observation combined with exact and objective recording. Finally, the benefit of sharing data before publication so as to put forward conflicting interpretations of the results. Notwithstanding these commendable attributes, nobody today would have condemned the editor if he had rejected such a speculative, uncontrolled, and unreplicated study. Irrespective of the perceived inequalities of the study design, it is difficult to overstate the importance of Ross's paper. The award of a Nobel Prize hardly does justice to the subsequent impact of his conclusions. The biological significance of the paper lies in 3 areas: basic research, malaria transmission and epidemiology, and the identification of what is perhaps the most vulnerable stage in the parasite's life cycle for effective intervention. The last was very quickly recognized, inevitably in a military political context, and resulted in the rapid adoption of environmental vector control campaigns, personal protection and house greening to prevent contact with the adult mosquito, and water management to destroy larva breeding sites. These were followed in the 1930s by the introduction of effective insecticides, including the wonder compound DDT, which, together with the new anti-malarial drug chloroquine, formed the foundation of the ill-fated but very successful global control campaign of the 1950s and 60s. Well, there's a second part in the article of Robert A. Sinden, skipped here, that deals with the history of malaria since the contribution of Robert Ross. It goes further into details about later stages, and which here was only formed the broadest outline. Well, you can find the article if you follow this link. I will put it in the description, and the same can be said for the enlarged lecture of Ross. The original text is not available anymore, it seems. He later wrote a book basing himself on that lecture. And you can go to the Nobel Prize site. And I shall also put the link in the description. And here, from the book by Ross, some more illustrations that he made. Beautiful drawings. These are the last of these 9 plates he made. And here in the book also, of course, point to that some extra data on his research. Well, that's it. Thank you for watching, and maybe till another time.